He composed the most celebrated music in Western civilization, and he never knew the man he called. Father wasn't his biological ancestor. Ludwig van Beethoven, born in Bonn, crowned in Vienna, the composer who wrote symphonies while going deaf, whose music defined an entire century of human expression. For 200 years, his death was a medical mystery. Lead poisoning, syphilis, alcoholism, hepatitis. Every generation of physicians offered a different diagnosis, but Beethoven left behind something no other composer of his era did. Authenticated locks of his hair, preserved in lockets and collections across Europe for nearly 2 centuries. In 2023, a genetics team sequenced his entire genome from those locks. They solved one mystery, and they uncovered another that no one saw coming. The team was led by Tristan Begg at the University of Cambridge. Their mission was straightforward: extract Beethoven's genome, identify the cause of his deafness, determine what killed him. They began by authenticating 8 locks of hair attributed to Beethoven. 5 were confirmed as genuine through DNA matching, all from the same individual. 3 locks failed authentication. 1, the famous Hiller lock that had been tested for lead in previous studies, turned out to be from a woman. Decades of lead poisoning research had been conducted on the wrong person's hair. The lead poisoning theory, built on decades of analysis, had been constructed from a stranger's hair. The real Beethoven's genome told a completely different story. The first piece of evidence came from Beethoven's own DNA. What it said about his health. Beethoven's genome contained hepatitis B virus sequences, active infection at the time of his death, combined with genetic risk factors for liver disease and documented heavy alcohol consumption. The cause of death became clear. He carried genetic variants associated with increased risk of liver cirrhosis. Add hepatitis B, add the alcohol consumption documented by his contemporaries. His liver never stood a chance. 2 centuries of competing theories resolved. Not lead poisoning from the wrong person's hair. Not syphilis, for which no genetic evidence was found. Liver failure from a perfect storm of biology, virus, and behavior. But the deafness remained unexplained. No single gene or infection in his genome could account for the progressive hearing loss that defined the final third of his life. The genome that explained his death couldn't explain his silence. Some mysteries outlast the sequencer. The second piece of evidence is where the investigation detonated, because the team also tested the Y chromosome. Beethoven's authenticated hair samples carried a Y chromosome that didn't match any living male line descendant of the Beethoven family. The team had tested 5 living men who traced their male line back to Ert van Beethoven, Ludwig's great-great-grandfather, born around 1600. All 5 carried the same Y chromosome. Ludwig's hair carried a different one. Somewhere in the 7 generations between Ert van Beethoven and Ludwig, a woman in the Beethoven line had a child with a man who was not her husband. The third piece of evidence narrowed the window. The researchers couldn't test every generation directly. Most Beethoven ancestors left no surviving male line descendants to sample, but they could narrow the window. The break occurred sometime between the conception of Hendrik van Beethoven in Kampenhout, Belgium, around 1572, and the conception of Ludwig van Beethoven in Bonn in 1769. 7 generations, roughly 200 years. Somewhere in the villages and towns between Flanders and the Rhineland, the biological Beethoven line diverged from the legal one. The researchers noted that the most likely window was the Flemish generations, where parish records are sparser and population mobility was higher during periods of warfare and religious upheaval. The fourth piece of evidence puts the Beethoven break in context, because it turns out this isn't unusual at all. Historical extra-pair paternity rates in European populations consistently measure between 1% and 2% per generation. Over 7 generations, the probability of at least one break approaches 10 to 14%. The same phenomenon found in the Plantagenet royal line. The same statistical reality that affects every extended family tree. Beethoven's broken Y chromosome is unusual only because Beethoven is famous. Richard III showed the same pattern, a Y chromosome mismatch across his patrilineal descent. 2 of the most scrutinized genetic lineages in history, both broken. Both perfectly normal by population genetic standards. The human family tree has never been as clean as parish records suggest. DNA simply makes the gaps visible. The fifth piece of evidence circles back to Beethoven himself, because he may have suspected something was wrong with his own origin story. Throughout his life, Beethoven believed, or claimed to believe, that he was born in 1772, not 1769. He resisted correction, even when shown his own baptismal record. Some historians speculated he was trying to appear younger. Others noted a more provocative possibility, that he questioned whether the man listed as his father was truly his father. There were persistent rumors in Beethoven's lifetime that he was the illegitimate son of a Prussian king, Frederick William II, or even Frederick the Great. Beethoven never denied these rumors directly. He occasionally seemed to encourage them. The DNA neither confirms nor denies a royal connection. Without a known Y chromosome profile for the Hohenzollern candidates, the comparison is impossible. But the break confirms that someone in the Beethoven line was not who the records claimed. The break could have occurred 5 generations before Ludwig was born, or it could have occurred with his own conception. The DNA can't distinguish between the two. But here is the twist. The Y chromosome break, for all its drama, changes nothing about Beethoven's music, and everything about how we understand genius. For centuries, the Beethoven family was studied as a case study in inherited musical talent. His grandfather was a Kapellmeister. His father was a court musician. The lineage suggested genius ran in the blood. But if the Y chromosome doesn't connect Ludwig to his supposed patrilineal ancestors, the inherited genius narrative fractures. The musical lineage the family claimed may not be the biological lineage Ludwig carried. His talent was his, not his grandfather's chromosome, not his father's genetic legacy. The Ninth Symphony didn't come from a Y chromosome. It came from a man. The genome of the greatest composer who ever lived contained no known genetic markers for exceptional musical ability. The search for genius in DNA came up empty. The Hiller lock tells a cautionary tale about building science on unverified assumptions. For decades, the Hiller lock was the most studied Beethoven relic in existence. Purchased at auction, tested for heavy metals, published in books, cited in medical journals. The lead levels found in the Hiller lock were extraordinary, over 40 times normal. Entire books were written about Beethoven's lead poisoning. Theories about lead-contaminated wine, lead-glazed pottery, and lead-based medical treatments filled academic journals, all based on a woman's hair that had been mislabeled sometime in the 19th century. The provenance chain, the bedrock of forensic evidence, had failed. The second case study is what the real hair actually contained. The 5 authenticated locks produced a genome of remarkable quality for a 200-year-old sample. Hepatitis B infection confirmed. Genetic predisposition to liver disease confirmed. No evidence of syphilis. The genome also confirmed his European ancestry, consistent with his documented Flemish and German heritage. No surprises in his population genetics. The surprise was purely in the family line. His final illness, documented in agonizing detail by his friends and physicians, now had a molecular explanation. The jaundice, the abdominal swelling, the repeated fluid draining from his abdomen. Textbook end-stage liver disease. The third case study confronts the implication nobody wants to discuss: what the Y chromosome break means for genetic genealogy itself. At 1 to 2% per generation, roughly 10% of family trees spanning 7 generations will contain a break. Go back 15 generations to the 1500s, and the probability exceeds 25%. Every ancestry test marketed to consumers carries this invisible asterisk. Your patrilineal story may diverge from your genetic story at any point along the chain. Beethoven's family didn't know their line was broken. No family does until someone sequences the DNA. The gap between the record and the reality is invisible without molecular evidence. The Beethoven case isn't a scandal. It is a statistical demonstration, one that applies to every family tree in every archive in the world. 3 case studies: a misattributed relic that derailed decades of research, a genome that solved one mystery and deepened another, and a statistical reality that quietly undermines every family tree on Earth. The molecules didn't care about the music. They just told the truth about the man. So what does Beethoven's genome actually tell us? That the man who heard music no one else could hear was carrying a virus, a genetic predisposition, and a broken family line, and none of it mattered to the notes he wrote. His genome contained the recipe for liver failure. It did not contain the recipe for the Ninth Symphony. That is not a limitation of genetics. That is the most important finding of all. The things that destroy us, viruses, genetic vulnerabilities, accumulated damage, those live in the genome. The things that make us extraordinary do not. His genome explained how he died. It couldn't explain how he composed. A man who wrote his own obituary at 31 because he thought deafness would end him. and then composed for another 25 years. DNA found the hepatitis. It found the liver risk. It found the broken lineage. It could not find the music. The evidence file is complete. 5 lines of investigation. Death explained. Lineage broken, genius unaccounted for. And 2 centuries of lead poisoning research, built on the wrong person's hair, quietly retracted. His molecules survive in lockets and archives across Europe. His music survives everywhere else. But Beethoven isn't the only genius whose DNA defied the story their family told. Across museums, private collections, and university archives, relics of the celebrated dead are being sequenced for the first time. And the deeper researchers dig into the DNA of the famous, the wider the gap between legacy and biology becomes. If the greatest composer's genome can't explain his music, what does that tell us about the search for genius in DNA? Which celebrated mind survives the sequencer? Which legacy doesn't? The relics are waiting. Locks of hair, preserved teeth, blood on manuscripts. The DNA of history's giants is within reach. If this investigation changed what you thought you knew, subscribe. Every case in this series follows the same rule. Start with the textbook, follow the DNA, and let the molecules speak for themselves. Beethoven composed for 35 years. His DNA waited 2 centuries to reveal what the music never could. All sources and peer-reviewed references are linked in the description below. The question isn't what killed Beethoven. We know that now. The question is where genius lives when it isn't in the genome. And that is a question no chromosome has ever answered.